1.
We have here a D2 system with a 780 nanometer DBR laser designed for rubidium spectroscopy. We have that spectroscopy signal generated with a D2-210 spectroscopy module. On the electronic side, we have a D2005 power supply, laser controller, the D2105, and a laser servo with a P-clock option, the D2125-PL. With these electronics, when you have your optics set up, you can sweep your laser frequency and see absorption to rubidium absorption lines. When you're ready to lock, a few things to take note of. One of the things that you need to set up before you lock the laser is the DC offset knob. This controls the center point of your error signal, which is what the servo is locking to. The servo is designed to keep this value at 0. And so right here, if we wanted to lock to the cycling transition of rubidium, right shown here, you're going to want to have the servo hold the value to be right here, right in the middle of this steep slope. And to do that, we want to look at the laser and make sure that that line right here corresponds to the ground signal of the error signal. So we're going to adjust the DC offset knob to get it right there so that when we look at it, we can see about an equal part above and below that line, maybe like that. And so now when the servo locks to hold this voltage right here, we're going to be holding the laser to be right at that dip in the spectroscopy corresponding to the center of that absorption line. The other thing you want to do with your oscilloscope before attempting to lock is notice where the ramp moves in and out. Right now, as I turn the ramp up and down, you see that there's a point that's not moving. That point's around there. I like to move that point to be centered with the oscilloscope so I always know where the ramp is going to turn off when you ramp it all the way down. To do that, I like to center a sharp peak, such as the cycling transition, on that point. So I'll turn the ramp down and center it as I go. So right there, we're centered. Then I turn the ramp all the way up, and I move that point to be on the center of the oscilloscope by changing the delay line on the oscilloscope. At this point now, I know that when I turn the ramp all the way down, it's going to go to exactly where it was on the center of the oscilloscope. This enables me to set the lock point very carefully, even when I have a strong ramp. So right now, when I flip the lock switch on, it locks right to that cycling transition there. Or if I move over a little bit to, say, one of these crossover peaks and flip the lock switch there, it locks instead to that point.